Okay, hi guys. Today I'm going to show you how to sketch parabola by completing the square. Now, this might be a bit of a longer video. I'm going to try and go through it as quick as I can to shorten the video, but if obviously you need, just pause, take some notes, rewatch the video, and hopefully it'll sink in. I want to just go back and have a look at, I guess, some of the forms we've seen, the quadratic equation. Obviously we see in the form of y equals ax squared plus bx plus c, but also in the form y equals ax take h all squared plus k. You know, h obviously represents the horizontal translation, k the vertical translation, and this form is really good for us to read the vertex from. We call this the vertex form of the quadratic equation. So basically what we're going to do is look at an equation that's written in the form of ax squared plus bx plus c and do completing the square, or factorizing by completing the square, to try and put it in that vertex form, so we can, I guess, have a starting point to start sketching it. Then we'll determine its y-intercept, its x-intercept, if there are any, and then sketch from there. So this first example I'm going to go through y equals x squared plus 6x plus 15. We're going to start by completing the square. And if you remember back to completing the square, what we need to do is we need to add in here the value of b over 2 all squared, but also subtract the value of b over 2 all squared to try and balance that equation. So I'm going to go ahead and rewrite this equation in the form of y equals x squared plus 6x plus the value here of b is positive 6, so I'm going to write 6 over 2 all squared. Again, I'm going to subtract that to balance out the equation, and the constant term 15 stays the same. Now the reason we're doing that is to get a perfect square in this front part of the equation. So this then simplifies to x squared plus 6x now plus 6 over 2, 6 divided by 2, which is 3. 3 squared is 9, so plus 9. We're also going to take the same 6 over 2 squared, or 3 squared, or 9, and add that constant term 15. This gives us the perfect square right here. That's what we're talking about. Okay, so two numbers that add to give us 6, multiply to give us 9. I mean, that number is obviously positive 3 and positive 3, so factorized, we can write it as x plus 3 all squared. Then we have minus 9 plus 15, which is positive 6. Okay, from there, obviously we've worked out the vertex now. Remembering back to some of the stuff we've done earlier in the parabolas topic, our vertex is at coordinates minus 3, okay, positive 6. Gives me an axis of symmetry of x equals minus 3. Remember, the axis of symmetry is the same as the x value in your vertex. Okay, so if I was going to go ahead and plot that parabola, I've got a Cartesian plane drawn up here. We need obviously to look at the point minus 3, positive 6 as our vertex. So minus 3, 1, 2, 3, and positive 6, 1, 2, 3, 4, 5, 6 is here. Okay, that's our starting point for our parabola. Now, what we can do next is to work out or determine our y-intercept. So I might do that on this side of the page. So our y-intercepts. Remember, when we're working out our y-intercept, the x value is going to be equal to 0. Okay, so I've got two forms of the equation here. Y equals x squared plus 6x plus 15, or y equals x plus 3 all squared plus 6. They're the same equation essentially, but I think it's easier to determine the y-intercept using this original formula. So what I'm going to do for x is I'm going to substitute in 0. So y equals, instead of x squared, 0 squared, plus 6 times 0, plus 15. Okay, now if I was to solve this, y equals 0 squared is 0, plus 6 times 0 is 0, so 0 plus 0 plus 15 is 15. And remember, your y-intercept is a set of coordinates. And that's going to be the x value of 0 and the y value of 15. Okay, so if we're going to go ahead and plot that, positive 15, 6, 7, 8, 9, 10, 11, 12, 13, 14, and somewhere there. I know this is my axis of symmetry. Okay, I also can determine that knowing that parabolas are symmetrical. Also the value of A being positive 1, knowing that my parabola will open upwards. This is also a point on my parabola. So based on that, I can actually look at it and say, well, you know, this parabola is not actually going to be crossing the Y-intercept at all. So there are no Y-intercepts on this parabola. And that point again was 0, 15. You can also determine that because when we got to this point here of our completing the square section, the two terms, x plus 3 squared and 6, are separated by an addition sign. So we can't fully factorize this using difference of perfect squares. Okay, if we could, then we could work out what the x-intercepts would be. Because there's a positive sign here separating those two signs, it means there's no x-intercepts. Okay, because we can't fully factorize that by completing the square. Okay. Perhaps what I'll do is I'll give you an example where we can go further and our parabola will cross that x-intercept or that x-axis. So let's look at the equation. Let's go with x squared. Let's do plus 8x plus 7. Okay. So the value of b in this equation is positive 8. So again, first step is to factorize by completing the square. So let's go with y equals x squared plus 8x plus 8 over 2 all squared. We can also subtract 8 over 2 all squared to balance that equation. Plus 7 stays the same. Okay. Eight over 2, 8 divided by 2 is 4, 4 squared is 16, so plus 16. We're going to take 16 and add 7. Okay, this is the part we're looking at here for the perfect square. Okay, which hopefully you've worked out now is x plus 4 all squared. Minus 16 plus 7 is minus 9. Okay, so already we know the vertex, we can determine the vertex of this parabola. The vertex will be equal to -4, -9. Axis of symmetry, x equals, same as the x value in the vertex, -4. Okay, now we can actually we can further go ahead and look at some x-intercepts. But actually, before we do that, let's keep it simple to start with. Let's look at the y-intercept. So we'll try and we've got plenty of room over here. So again, with the y-intercept, remember x value is going to be 0. Let's go back to this original expression or equation rather. So y is going to be equal to x being 0, 0 squared plus 8 times 0 plus 7, which gives me a y value of 7 and a y-intercept of 0, 7. Okay, so if I was going to actually, let's go ahead and plot these points first. So -4 and -9 as my vertex or turning point. So -4, 5, 6, 7, 8, 9, -9. Okay, obviously my axis of symmetry is also -4. So that's the imaginary line that splits that parabola in half. You know, parabolas are symmetrical. We've also got a y-intercept of 0, 7. So we can go ahead and mark that here. So 1, 2, 3, 4, 7. And I guess looking at this, we know that our parabola is going to in fact cross the x-axis here, and it will cross twice. Again, this parabola is going to be opening upwards because the value of a in this case, again, is a positive value, +1. So I'm going to show you the final step, and this is I guess the trickiest part. I might have to just move the page up a bit, so sorry about that, guys. What we need to do is look at this step we've got here, the vertex form, which is x plus 4 squared take 9. We can factorize this further using difference of perfect squares. So remembering back to that procedure, okay, essentially we've got two sets of brackets. The square root of x plus 4 squared is simply x plus 4, so that goes at the front, both sets of brackets. The square root of 9, well 9 is an easy example because 9's a nice square number, so the square root of that is 3, so that goes at the back end of the brackets, and then we're separated by a plus and a subtraction sign. Now inside these brackets we've actually got some like terms. 4 and 3 and 4 and minus 3 are both constant terms, or all constant terms, so we can sort of collect those inside that bracket. So x plus 4 plus 3 becomes x plus 7, and x plus 4 take 3 becomes x plus 1. Now, what we're actually doing is determining our x-intercepts. In this case, y is going to be equal to 0. Okay, so all of this is actually equal to 0. So x plus 7, x plus 1 is equal to 0. And this is where the null factor law comes into practice. So where the null factor law, excuse me guys, tells us that if two terms multiplied together equal 0, then either this term is equal to 0 or this term is equal to 0. So in this case, if x plus 7 times x plus 1 is equal to 0, then x plus 7 must be equal to 0, or x plus 1 must be equal to 0. If x plus 7 equals 0, then x is equal to minus 7, so obviously I'll subtract 7 from both sides, and x is equal to negative 1 in this case, which gives me two x-intercepts of negative 7, 0, and negative 1, 0. And if I was to plot those on my Cartesian plane, negative 7, 0, negative 1, 0, 1, 0 right there, negative 7, 0 would be over here. Okay, and again, I've got enough points now to actually plot. I can actually put a fifth point in there, understanding that parabolas are nice and symmetrical. Go ahead and plot that and sketch my parabola as accurately as I can on here. Like so. Okay, so hopefully that helps. This is going to help you guys with question 8 that we did today. And I believe, from memory, it was on page 452 of your textbook. So have a go at those questions. Watch the video, like I said, pause it when you need to, and good luck.